A software company develops two types of applications, mobile apps and web apps. Each mobile app requires 50 hours of coding and 20 hours of testing. Each web app requires 80 hours of coding and 30 hours of testing. And the company has 4,000 hours of coding time and 1,500 hours of testing time available. And the profit from each mobile app is $500 and the profit from each web app is $700. I am going to formulate a linear programming problem to maximize profit. So we are having that problem there. So to formulate the linear programming problem, I will look at the following steps. Number one, I will identify the decision variables. Number two, define the objective function, then go on and formulate the constraints, and then look at the non-negativity constraints, and then write the complete linear programming problem. So I'll start by the first one there, identifying the decision variables. So for the variables, we are saying what is it we can vary so that we maximize the profit. So what you can vary there is the number of mobile apps that are to be made, and you can call them M. And we can also vary the number of web apps that can be made, and we call them W, just as a symbol there. So these are the variables that we can change so that we change the value of the profit. Then for the second step, we now go on to defining the objective function. The objective here, we are saying you are formulating a linear programming problem to maximize profit. So that's what you want to do. We want to maximize profit, but we also need to look at the information on profit. It is saying that the profit from each mobile app is $500, yet the profit from each web app is $700. But in this case, we are saying we are making M mobile apps. So the profit from mobile apps will be 500 times M, and the profit from web apps will be 700 times M. And the total profit now will be the sum of the profit from mobile apps and the web apps. So in this case, we'll be maximizing Z, which is equals to 500M plus 700W. So that's our objective function there. I now move on to the third step, trying to formulate the constraints. To do this, I'll look at the limitations that we have. If we see here, we see that we are having 500 hours of coding for each mobile app and 20 hours of testing for each mobile app. So to see this clearly, I find it convenient to draw a table that we have the mobile app, the web app, and then we have the coding time and the testing time. So on the highlighted part, we are saying each mobile app requires 50 hours of coding. So if it has 50 hours of coding, I'll put the 50 there. And it requires 20 hours of testing, so I'll put 20 there. And then for the web apps, we have that they require 80 hours of coding. Yeah. So I'll write 80 here. Then we are also saying that they require 30 hours of testing, so I write 30 hours there. Now go on and look at the constraints that we have. And the company has 4,000 hours of coding. So when we add the coding for the mobile app and the web app, and the total time should not exceed 4,000. And it has a maximum there of 1,500 hours for testing time available. So we have the testing time there, the total should be 1,500. So in this case, for our constraints, what you are having there, the constraints are the hours that are highlighted there, the coding and testing time. So I now have the information in a table there. I now go on and formulate the constraints. So looking at this first row here, where we are having coding, we are saying each mobile app requires 50 hours and each web app requires 80 hours of coding. And we are making M mobile apps and W web apps. So the total number spent on coding will be 50 times M plus 80 times W. And we are saying it should not exceed 4,000. So our constraint there will be 50M plus 80W is less than or equals to 4,000. Then go on and look at this row where we are now having the testing time. Each mobile app requires 20 hours of testing. Each web app requires 30 hours of testing. But we are making M mobile apps and W web apps. So the time spent on testing there will be 20 times m plus 30 times w, and we are saying it should not exceed 1500. So it will be less than or equals to 1500. So our constraint there will be 20m plus 30w is less than or equals to 1500. But here we say that we are making number of things there. So we need to look at now the non-negativity constraints so that we don't have the m and w being negative. So we would have that m and w are greater than or equal to 0. So we now go on and write our complete linear programming problem. So for the complete linear programming problem, we are combining the constraints and this objective function here. So our linear programming problem there is maximize set, which is equals to 500m plus 700w, subject to the constraints 50m plus 80w less than or equals to 4000, 20m plus 30w less than or equals to 1500, m and w greater than or equal to 0. So this is our linear programming problem. So that's our solution there.